Romp is a web app environment intended for rapid IoT application development. It handles communication, security, authorization, packaging, and deployment automatically. It implements the Flux model and is built using React. It is deployed with Webpack for on-demand loading of efficient apps. Designed to be wrapped by a native app. And it has full access to a device's communication stream. Flux is an alternative to the MVC architecture approach. The main motivation for adopting Flux is that it reduces complexity and lowers the cost of upgrades and maintenance. The basic flow of Flux starts with actions. When something changes, an action is triggered. Actions have types and payloads. Depending on the type of the action, it can optionally be dispatched using the dispatcher. The dispatcher handles broadcasting of the action to interested stores. It also manages store registration. A store registers with the dispatch and is then notified when an action occurs. An application can have many stores, each handling different actions for various components. A store is essentially the data or state storage. When the data or the state change because of an action, the store handles the change and produces the new state. Finally, the view is the UI rendering component. It registers a callback with the store to notify it when there is a new state. In Romp, the UI rendering is handled by React components. The important thing to understand in this architecture is the nature of the unidirectional data flow. The view does not modify the state directly. All changes must flow in as actions. The format for communication with a device is based on JSON. This makes it easy to construct, send, and receive data to and from a device. Do check out the API documentation to learn more about all the possible API calls. If your device is not a known supported device, you can request that it be added by contacting RC Developer Support. When your app starts, you can assume the following values are available: the device identifier, the selected endpoint on the device, and the app ID category the device falls into. Romp takes care of adding the correct device ID, endpoint, and gateway ID for all your outgoing calls. The endpoint is the only parameter that can be overridden. The simple switch app demonstrates how easy it is to build a Romp app and control a light switch. For this tutorial, we will assume a Unix, Mac, or Linux environment. The first thing to do is ensure that you have the latest version of Node.js. Here we checked out a copy of Romp from GitHub. And now we're installing Webpack and React tools globally. Next, we let npm install all the required packages. And now we start npm in the background. After the first initial build, we're ready. Now we go to the Chrome browser and open Romulator, the Romp simulator. Let's enter a server name, a username, and password, and then connect. I'll select the gateway, the device, and the endpoint. And now we see Romp running in the browser. You'll notice that clicks are ineffective. That's because Romp is a touch app. To turn on React Touch support, right-click and select Inspect Element, and make sure you selected the mobile device mode. You may have to refresh. Now you'll see Romp react to your clicks. You can also notice that all communication is visible in the console. One interesting incoming call is the info device, which will contain all the basic data for our device. Feel free to inspect the device info data. Next, we'll open the source code in the Atom editor. In the source directory, you'll see all the source code for Romp. The apps directory is where all Romp apps reside. For our simple switch application, we're going to create a directory called simple switch. Romp apps are required to have 3 files. The first one is the init file, so we'll create it here, init.jsx. It includes simple initialization code for your app. For now, we'll just import Romp actions, and we'll export one default function. The second file is the icon file. We can copy the default Romp app icon file from the Romp images directory. And here's how it looks like. Finally, the main app file needs to have the same name as the directory it resides in, ending in the .jsx extension. For our app, it'll be called simpleswitch.jsx. Here you can use any JavaScript flavor. Romp supports ES6, so we'll start using that notation. This is the UI component, so we'll import React. Then we'll import the Romp store to get the state, and then we'll import Romp actions, and optionally Romp translate. Next we create the React component class, and we name it the same name as our file. So here we name it Simple Switch, and it extends the React component class. Then we create a constructor and pass along any props to the superclass. Next we create a state change callback, which is simply a local variable. We're going to bind the current this scope to the function named state changed. Next we define a local state. The local state is the device that we get from the Romp store. Next we create a function called component didMount. In there we will link up our state changed callback function to the Romp store by calling add change listener. When our component unmounts, it'll remove that listener. Now we define our state changed callback function, and all it does is ask the Romp store to give it back the state again. By calling setState, we trigger re-rendering of the React component. This will update our UI when something changes in the state. The render function returns a simple div with a simple text message. And this concludes a bare-bone Romp application. Next, we need to add it to the Romp directory. Open the Romp directory file and just copy and paste an existing app. Here we'll change the name, the URL, and the app IDs this application supports. In this case, we're really interested in 0101 and any group app IDs. Now we set the label and set the icon path and the init path. Finally, we set the full path to the application file. Now if you hit save, you'll see a new Romp application pop up. Here it is. If we click, we'll see that our app renders perfectly. Let's try a quick modification. Hit save and see it update live. Let's try printing something from the device state. Let's try printing out the name. And also the ID. Please note that this information is coming live. So if the device changes names, you'll see your application change names automatically. The next thing to do is to show the exact state of the device, whether it's on or off. For an on-off device, we'll look up the endpoint that has the app ID 0101 and then look in the in caps for cluster ID 0006, which will have the on-off attribute set to 01 or 00. Here we'll just paste a function called isOn that will traverse the device and pull out the exact state of the device. By default we'll assume it's false, and then go through all the endpoints of the device looking for the 0101 endpoint, go through the in caps, find the 0006 end cap, and check its on-off attribute value. Now when we're rendering, we use the isOn function, passing it the current device state, And whether it returns true or false, we set the label to on or off. And now we just print the label. Great, now let's send a toggling command. Let's start by defining a toggle function. And depending on the current state of the device, if it's on, we'll send an off-device action. Otherwise, we'll send an on-device action. Now we'll just add a toggle button and set the click handler to our toggle function. To make the button look more like a button, we'll set the class to Romp button. Now we have a button that toggles the device on and off. Notice how we send the command and our UI component correctly renders the state of the device. This is all happening in real time. The last thing you'll notice is that the back button doesn't work. This is because Romp requires every app to have a back handler. This gives your app a chance to save any data or do any cleanup it requires before it goes back to the main navigation. So now we just add a back function, and the only thing it does is call romp actions goto hash. When the component mounts, we need to push our back handler into Romp, and when we unmount, we pop it out. And now you'll see our back button works, and we're done building our first Romp app. When you're done building your app, contact ROC Developer Support to take your app live.